Hello children, welcome to the science class. I, Geeta Jain, science teacher of class 6, welcome you all. In the previous session, we have studied about how to measure the line with using the ruler or the meter scale and what precautions we are supposed to take care while we are measuring with the ruler. In today's session, we are going to study about measuring the length of a curved line. What do you understand by the curved line? The line which is not straight, which is not straight. What do you understand by not straight? That means a wavy line is known as a curved line. How can we measure it? Can we measure it with the meter scale? Of course, the question may come, no ma'am, we cannot measure the length if it is curved with the help of the meter scale. Then how can we measure it? Let's find it out. Okay, to measure the curved line, meter scale is not used to measure the length of a curved line. What do we need? We need a thread to measure the length of a curved line. So how can we do it? How can we proceed it? Okay, so here on the screen it is given. Let us suppose that we have to measure the length of a curved line xy. What it is given? A curved line xy. You can see on the screen. Yes, a curved line is given, and how can we measure the length of this curved line? So what you have to do? You have to take a thread. Then you can see on the screen where the X is written. Put a knot on the thread. See, you can see over here, the knot is being put on the thread near one of its end. And what now they did? Place this knot on the point X. We have placed it on the point X. Now, what we will do? Now keeping the thread taut by using fingers, that means place the thread on the curved line and fingers and the thumb, and place a small portion of the thread along with the line. You can see in the figure how the thread is being placed on the curved line as shown. You can see over here very clearly. Holding the thread with one hand at this point, stretch a little more portion of the thread along with the curved line with the other hand. So keep the thread on the curved line and reach to the end point of the line, and there you go. And what you will do? Yes, you will break the thread, and you have to repeat the process, the same process. You have to reach till the end of the line, and you have to repeat the same process till you reach to the end point of the line, that is the Y. And now here what will happen when once you reach to the end point? Now break the thread, take a ruler and stretch the thread and measure the length. You can see over here. Yes, stretch the thread along with the meter scale and measure the length between the initial and final marks. This is the required length of the curved line XY. I think all of you are clear with that. What you have to do? The line which is being drawn or which is being curved, take a thread, tie a knot at the one end of the thread, put the knot of the thread on the initial or the starting point of the line, and place the thread along with the line, reach to the end point, cut it and stretch the thread and measure it with the ruler scale. I think now this portion is clear. So about the measurement, we have cleared everything. As in the beginning only I have told that this chapter has been divided into two parts, measurement and the motion. So the measurement part we have completed. Now we are starting with the another interesting topic of this chapter, that is motion. Okay, so moving things around us, if you see around you, you will see that each and everything is moving. You see that the birds are moving, you see the vehicles are moving. Yes, so many things are moving. So we will see that what type of movement they are showing to us. Before we start, let's watch a video so that you have a clear idea about the movement.
Have you seen a hummingbird hovering around the flowers and extracting nectar from them? Which among the bird and the flower is in motion? You will see that bird keeps changing its position from one flower to other, while flowers remain static at their original positions. Object which changes its position with respect to time is said to be in motion. On the other hand, objects which do not change their positions with respect to time are said to be at rest. Whenever an object is in motion, it covers a certain distance in a particular direction in a specific time period. Now, let us see around and see that which of the things are moving and which are at rest. At your home, objects like chair, table are at the position of rest, while the hands of the clock and blades of ceiling fan are in motion. On the road, you can see the traffic lights and plants are at rest, while the vehicles are in motion. In this way, all the things around us are either moving or at rest.
So what is motion? Actually, if I say what is motion, so very clearly you can say that motion means when an object changes its position with respect to time. So along with the time, if any of the object changes its position, we call it as motion. If the object is at its place, not moving at all, then we can say that object is at its stationary position. Clear? I think the term motion. Motion means change in the position of an object with respect to time. Now we will see the types of motion. There are various type of motions. So let's see the type of motion. Now watch a video so that you will have a clear idea about it.
Motion. Motion is the change in position of an object with respect to the observer. In daily life, we observe different types of motion, as here we can see the motion of soldiers in march past, the motion of blades of table fan, the motion of pendulum of the clock, and many more. The various types of motion are rotatory motion, circular motion, oscillatory motion, vibratory motion, and translatory motion.
Okay, here we have seen the various types of motion. Yes, you have seen in the video that there is a rectilinear motion, there is a rotatory motion, there is a circular motion, there is a periodic motion, there is a vibratory motion. So now in detail we will study about the motion. The first type of
motion. In the rectilinear motion, an object moves along a straight line. It is a type of translatory motion. Let's see an animation for better understanding.
Rectilinear motion. That means when an object is moving in a straight line, then we call it as a rectilinear motion. If I talk about the translatory motion, that means the whole body is moving along the object. That means the whole object is moving. That type of motion is known as a translatory motion. So rectilinear motion, and the one is the curvilinear motion. Rectilinear means when the object is moving in a straight line. Curvilinear when an object is making a curve. So how can you understand? The simple example I'll just share over here. If you're standing on the rooftop of your building, suppose if you are living in a building and you are standing on the rooftop of your building, and if you throw a ball from the top of the building to the ground floor, how will it fall? Of course, it will fall like this in a straight manner. That sort of motion is a rectilinear motion. But what happened now? You are standing on your building. You two friends are there. One is standing on the other one corner and your friend is standing on the other corner. What will you do? How will you throw the ball? So you will throw the ball like this. So what will happen? What the ball has made over here? Yes, the ball has made a curve over there. So that sort of motion is known as a curvilinear motion. They both come under the category of translatory motion. You would have seen the birds flying. How does the bird fly when it's sitting on the ground? Of course, it take a flight. How does it take? It makes a curve and then it takes a flight. That is again an example of curvilinear motion.
Translatory motion. The motion in which all the particles move through the same distance in the same time. In translatory motion, an object can move in a straight line or along a curved line. This can easily be seen in case of motion of a bicycle which follows a straight line path and the motion of football which follows a curvilinear path.
Okay. Here you can see how the ball is making. When you are throwing the ball, what happened? How does it's making a curve? This is a curvilinear motion. Okay, I think now you all are clear with the rectilinear motion and the curvilinear motion. They both come in the category of translatory motion. When an object moves in a straight line, we call it as a rectilinear motion. And when an object makes a curve and move, we call it as a curvilinear motion. Now let's watch. Now understand the example of rectilinear motion.
We know that both a ball falling down and an apple falling from a tree are the examples of rectilinear motion.
Yes, that same
Let's
example.
Let's now study about the other two types of motion, rotatory and circular, through an animation.
Okay. Rotatory and circular. Before you watch in this animation, I just want to make you understand. Rotatory motion means when an object is fixed at one place and moves. That means is fixed at one place. That is known as a rotatory motion. Circular motion means when an object moves in a circle. You can understand by this, the earth, the sun is at the center and the earth is moving in its orbit. Yes, in the circular path it is moving. That motion is known as a revolutionary motion or circular motion. Because of that, your seasons are changing and the year is changing. Okay. While if I talk about the rotatory, that means it's on the one place and it's rotating. It's known as the rotation. That's on the fixed axis. When an object changes position is known as rotatory motion.
When an object moves about a fixed axis in such a way that each of its particles is always at a fixed distance from the fixed axis, the object is said to have rotatory motion. The top spins about its axis. For rotatory motion, different particles of the object move along concentric circles of different radii. We consider rotatory motion as the motion of the object that keeps on moving without changing its place. Motion of gramophone record.
Yes, you can see that it is fixed at one place.
Motion of blades of fan.
Fixed at one place.
Motion of potter's wheel are examples of rotatory motion.
Here you can see that all this example, it's fixed at one place, fixed axis, and they are moving.
Circular motion. When an object keeps on moving along a circular path, we call its motion as circular motion. The moon revolves around the earth, or earth revolves around the sun, are examples of circular motion. The circular motion is different from rotatory motion. The object in circular motion remains in the state of motion only as long as it is under the action of suitable external force. If this external force is removed, the object then follows straight line path. But in case of spinning top or potter's wheel, the rotation can be seen even when external forces are removed. It may slow down due to frictional force, but it keeps on rotating.
Okay, I think now all of you are clear with the rotatory motion and the revolution and the circular motion. Rotatory motion means when an object moves at this fixed position. Circular, when an object moves in a circle. I can share this example with also giant wheel. You all would have seen the giant wheel, yes? So if I say the shades of the giant wheel is showing us the rotatory motion because it's a fixed with the axis. But if you are sitting in the giant wheel and if I ask which motion you are presenting over here, that means you are showing the circular motion. One more example, the blades of the fan, they all show us the rotatory motion. But if I made a mark, if I make a mark on one of the blade, corner of one of the blade, and the fan is rotating, what about the motion of that point which I made? Which sort of motion would it be showing us? Yes, it will also showing us the circular motion.
When a body repeats its motion after a fixed interval of time, then it is said to be in periodic motion.
Okay. The next type of motion is a periodic motion. We have studied about translatory motion. In translatory motion, there are two types of motion, rectilinear motion and curvilinear motion. Then we studied about the rotatory motion and the circular motion. Now we'll study about the periodic. The name itself says periodic. That means it is changing after some time, as a fixed interval of time. That means when a body repeats its motion after a fixed interval of time, then it is said to be an periodic motion. Like the earth rotation, earth revolution, these all are the periodic motion. You all would be playing with the branches of the trees. What do? You pull the branch down and then you leave it. What happened to the branch? Then it starts moving like this. From the mean position, it goes up, comes down, goes up, comes down. There's also an example of a periodic motion. Keep your hand on your heart. How does it beat? Yes, after a fixed interval of time, you hear the beats of your heart. Is again an example of a periodic motion. If you are playing a musical instrument like guitar, okay, how, if you play the strings of the guitar, how does it move? Again, from the mean position, they go to and fro. Again, they after the fixed interval of time, they come to the mean position. That is again known as your periodic motion. You would have seen the pendulum of a clock, which also moves to and fro from this mean position, is also an example of a periodic motion.
Here we can see some of the examples of periodic motion.
Here you can see that what I was talking about, the pendulum. Yes, from the mean position, it's going to and fro. Yes, as an example, that after a fixed interval of time, it is coming to the mean position. Here also, when the child is swinging on a swing, the motion of a child on a swing is again an example of a periodic motion.
In many situations, a body is in more than one type of motion. Such a body is said to exhibit a combination of motions.
Yes, where when one object is showing more than one type of motion, it's not necessary that it will show only the one type of motion. It may show the different types of motion. So first example they had given about the wheels of vehicle. So you can see over here, when a person is cycling, then the wheels of the cycle is showing us the rotatory motion while the cycle is moving in a rectilinear motion. So when a person is cycling, the wheels of the cycle while moving forwards, the rotatory motion, and the wheels of the cycle are simultaneously, it is showing the rectilinear motion. Rectilinear motion means when an object moves in a straight line, rotatory on the fixed axis, and an object moves is an example of a rotatory motion. So the wheel of a vehicle is showing both the motion, rotatory as well as rectilinear motion. The next example, swing machine. Very common example. In a swing machine, we observe different types of motion taking place at the same time. You can see the needle of the swing machine. It is showing the periodic as well as the rectilinear motion, and it is going in a straight line. So rectilinear motion, periodic, because it's repeating after a fixed interval of time. After a fixed time it is repeating. So it is an example of periodic time. And rotatory, as the swing metal spindle, it's rotating. So it is an example of a rotatory motion. And the last and the third
The
example
Earth
is
moving around the Sun executes circular and rotatory motions.
okay, the Earth's motion around the Sun. It is showing both circular as well as rotatory motion. Circular means when the Earth rotates around the Sun is this elliptical path, the circular path. So it's an example of circular. And when the Earth moves on its fixed axis, you can see over here on its fixed axis, it is an example of rotatory motion. I hope you all would have understood the chapter. Thank you and keep learning.